the mass that is actually located to bringing about what a very low signal. At times it could even be based on the weather condition. Anything could happen, but engineers that are being used in different telecommunication sectors, all they just need to do is to decode where the problem is for and they fix it up. But what interconnects your phone in terms of connectivity, in terms of network signal, are all what radio waves. You know, microwaves are different from your radio waves. For microwaves does another job. Another job microwaves does is probably to, let's look at the actual meaning. They are shorter than your radio waves. Check it. Their wavelength is shorter, but it is used. We use microwaves for food. Now, what differentiates microwaves and radio waves is that microwaves function is all it does is to heat up a lot of things. You understand? When I say heat up, microwaves cook up a food particles. Not to even cook it up. Let me use warm. It warms up an environment. You get? It can warm up an environment. It can warm up a food. Food particles. It can warm up a soup. That's one beautiful thing about microwave. It sends signal. It sends particles, heat particles, to any particular body is being sent to. That's why you have your mini microwaves at home. If you probably prepare your soup and maybe you prepared it in the morning and at night you need to take the food in, and all you just need is, and you need to warm it. Just take part of it, or you take the whole part of it, can contain it, put it in your microwaves, and before you know it, just set it on 5 minutes or 10 minutes. Your food is already warm. So that's a very good example of your microwave. Now listen to the explanation. It said, you use microwave to cook food, it transmits information, and in radar that helps to protect the weather. Hope you are getting it. So these are the actual uses of your microwave. Microwaves are useful in communication because they can penetrate the cloud, they can penetrate smoke, and they can what? It can help in what? Light rain. Now let's go to infrared. Infrared is another example of your what? Of your electromagnetic wave. What does infrared do? Infrared waves are sometimes classified as near infrared or far infrared. The near infrared are the waves that are closer to the visible light in wavelength. They are the infrared that are used in your TV remote. I hope you are getting it. You know, infrared, we have explained your radio waves. We spoke about radio waves. We spoke about your microwaves. Now for your infrared, what does it do? If you are to check most TV stations, let's use the TV station now. If it is to be your TV station and you need to probably change your station or change the channel. A lot of people, gone are the days that you need to go and go to your TV and start tuning the knob for you to change your station. You ask me, how you are pressing the remote and the TV is responding. Something is actually being placed at the tip of your remote, and that particular thing is what we call your infrared light. Infrared light. It's a light, but you can't actually see it. But if you are to, it interconnects. There's what we call a sensor. There is a sensor at the tip of your remote, and there is a sensor somewhere close to your TV. But the designer of this TV, they don't make it something you can see. You get? But it's somehow buried at the surface of this TV. So it is the infrared of this the sensor of this remote, which has an infrared light, and the sensor of your TV. So it is that connectivity that changes the station of the TV. If there is no connectivity, let's say if there is a barrier here, someone decides to stand in front of this place. No matter how you press the TV, for as long as the sensor here and the sensor of this TV are not connected, it's not going to what? It's not going to work. It's not going to change the stations. But engineers have gone advanced now that even leave your sitting room, go to the toilet. If you can press your remote, your TV station will change. You understand? So the engineering world or electronics world is changing by the day. You understand? So at that junction now, what they are actually being used is also an infrared, but it is an advanced form. There are infrareds that all they need to just do is to locate. You get? They work with what? They work with wireless. They work with wireless network. There's what we call wireless network. So there are some infrared light that works with wireless network. All you just need to do is that there are free Wi-Fi everywhere. So immediately the wireless network is connected with the sensor. Your sensor will definitely now connect your TV through your wireless. So that's why if you're in your toilet, if you press whatever station, your TV station will change. But believe you me, it has a maximum distance level. What I mean is that there is a particular distance you have to stay for this particular function to work. You can't leave your home now. Maybe you left from Lagos, you understand, and you went to Ibadan and you start pressing your remote. It won't work because you have exceeded the maximum distance. You understand? So that one too could work. So that's another very good example of your infrared. Another is what we call visible light. What are visible lights? Visible light spectrum covers the wavelength that can be seen in the human eye. These ones are not really common, but they exist. Another very good one is your ultraviolet. It's been discovered that ultraviolet waves is actually being what? It's coming into planet Earth. Now, what ultraviolet wave does is that it's depleting this protective cloud. We call it there's what we call stages of Earth covering. We have what we call the atmosphere. If you have done your biology very well, we have what we call the atmosphere. You can see from physics we are going to biology now. So science is what? All encompassing. You just have to be very good. Now there's what we call your ionosphere. There's what we call the lithosphere. Change it. Now, if we look, all these spheres are just what? Covering. They are just layers, after planet Earth that covers the planet Earth. You understand? To what? Avoid unnecessary what? Leakage of what? Dangerous substances outside in the universe. And this is outside this space is the universe, but this is planet Earth. But what scientists now discovered is that there is always leakage of what? Ultraviolet ray from what? External universe into the planet Earth. Now, what this ultraviolet ray does is that it's dangerous to human health, and at the same time, it's depleting. You understand? It's depleting the covering. When I say depleting, it's breaking that covering little by little. If you must have seen astronauts, you can Google to check. Who are astronauts? Scientists that goes out of what? Planet Earth, that visits the moon, that visits Jupiter. They can visit Jupiter, they can visit Mars. Mars is another planet. There's what we call Mercury. Mercury is the first planet. Venus is the following planet. Then we have planet Earth. After Earth, we have what we call the Mars. Mars is another planet. Now, in the United States, maybe you don't know, very soon, they are already trying to what? Build another world on planet Mars. You understand? Scientists are beginning to feel that very soon our planet Earth will soon go into extinction. When I say extinction, we have overcrowded it. A lot of destruction, a lot of catastrophe is happening on planet Earth. So scientists are planning another planet where human can live in. You understand? If you watch these astronauts, they will because for you to travel from planet Earth down to another planet, at times it takes 3 years. At times it takes 30 years. It depends on where you are going. What scientists discovered is that a scientist that left planet Earth, maybe he left at age 25. Let's say he's embarking on a 3-year journey. He gets to the moon or wherever. By the time he comes back, let's say he came back, maybe he's supposed to be 75 years old. Or 75 years old. And by the time he gets back, he will discover that some of his colleagues that he left behind are already old, as in they are older than him. He gets back and he's still looking very young. Why is that? Because the gases that he's being exposed to. You understand? I'm not saying it's very good, and I'm not saying it's very bad. But what I'm trying to say is that on planet Earth, we take in oxygen. We take in have gravity used to be experienced on planet Earth. But when you go out of this planet, there is no gravity. So definitely that confirms the fact that there are gases outside outside our planet Earth. So ultraviolet ray, that's what we are talking about. Ultraviolet waves is being escaped into our planet Earth and is depleting our protective cover. So that ultraviolet ray is an example of what? Electromagnetic waves. Let's go to the next one. X-ray. What is an X-ray? You must have heard about this one way or the other. Or some of you must have gone through some kind of surgical operation where this particular process is being required. Now, what's an X-ray? X-ray is just, if you must have done an X-ray before, you take your X-ray sheet or X-ray polymer material, you realize that it will showcase your bones. You get Now, it means that that light passes through the human body. You understand? But this bone that is actually showing could not be penetrated by that light, and that is why you are seeing what? The physical structure of the bone. Meaning that an X-ray penetrates a particular object. You know, in industry, you know what we use X-ray light for? But right now, engineers are looking into something else. We use X-ray to detect leakages. So you get, if you use it to pass, if you penetrate it through a particular cylindrical hole, so you get, if it's an X-ray, it's a very, very good X-ray, it will locate where this particular borehole, this particular cylindrical object is leaking. So you get what I'm trying to say? So those are some of the characteristics and properties of what? An X-ray. Let's look at what we have. We say an X-ray has shorter wavelength than your ultraviolet ray. You know, we said it the other time that the only ray that has the longest is your radio wave. Do you understand? Now, at this point in the electromagnetical spectrum, scientists begin to think of these rays more as what? Particles than what? Waves. Do you get? When I say particles, electromagnetic rays are beginning to be seen as particles. You have what we call your gamma ray. You can see you have X-ray, gamma ray. What's the gamma ray? Of the electromagnetic wave gets shorter, their energy will increases. So gamma rays are the shortest waves in the spectrum, and as a result, it has the most energy. So gamma rays are sometimes used in treating cancer and taking detailed images for what? For diagnostic of medicine. Two properties need to be known. We have